kids. Welcome to your astronaut training program.
Astronaut training? I thought we were here to ride roller coasters.
That's exactly right. I want you to be able to experience the thrill of space travel. And the best way to do it here on Earth is on a roller coaster.
What do roller coasters have to do with space travel?
I know that roller coasters go fast, but not nearly as fast as rocket ships.
That's right. But it turns out the thrill of space travel doesn't come from going at high speeds. It comes from accelerations.
We've learned before that acceleration is a change in speed or direction.
Precisely. The important point is that forces are needed to cause accelerations. Remember the law of inertia?
I remember. It states that objects at rest stay at rest, and objects in motion remain in motion.
Very good. Let's get this bowling ball rolling. What if I hit it from the side?
I would guess that it wouldn't change speed. I'm not sure what it would do.
Let's try it.
It changed direction without changing speed.
The same thing happens to the roller coaster car at the bottom of the hill. It has inertia and wants to maintain its downward motion, but the track pushes the car perpendicular to its motion and sends it uphill.
What does the push of the track do to the passengers?
It makes them feel heavy. The faster the coaster is going, or the tighter the turn, the heavier they will feel.
How heavy will you feel on a roller coaster?
Here on the Alpengeist, you feel about 4 times heavier than normal at the bottom of a couple of the hills. It turns out the space shuttle astronauts only feel 3 times heavier than normal when the shuttle is taking off.
So you were right. We are going to be in training to be astronauts.
The difference is, on the Alpengeist, you feel heavy for only a few seconds at a time. But on the space shuttle, you feel heavy for about 8 minutes.
Don't astronauts also feel weightless? Will we be able to experience that on the Alpengeist?
You bet. Once the engines are cut off after about 8 minutes and the shuttle goes into orbit, the astronauts are weightless. Weightlessness is experienced when only gravity acts on an object. It's called free fall. Let me show you. When I jump off this bench, the points of my hat will float as if they're weightless, and this spring hanging from my hand will collapse.
Wow, Dr. D, what you go through to show us how science works.
So where in the coaster ride are we going to be falling?
Free fall is not always down. Remember, it's when only gravity acts. So when I throw this koosh ball, watch which path it follows.
I've seen that before with the vomit comet when we were learning about habitats. I think it's called a parabola.
Very good. The coaster goes over a parabolic hill and twists at the same time. For a few seconds, you're weightless.
This is going to be exciting.
Can we go on the ride now?
One more thing. You can tell how heavy you feel by watching this accelerometer. When you feel 3 times as heavy as normal, this mass will be pulled onto this point right here. Einstein told us that being heavy on a roller coaster and being heavy on a big planet are the same thing.
So I guess we're preparing for both space travel and visiting an alien planet.
Let's go on the ride. I'm ready to be an astronaut.
Okay, it's good to experience the physics and not just talk about it. Don't forget to watch the accelerometer and try to figure out where you are when you feel the heaviest. Come on, let's go.
Ready? Let's go.
Here we go.
That was so great. I felt heavy at the bottom of the hills. I noticed the accelerometer read more than 3 a number of times, but I lost count.
I noticed I felt weightless a few times.
I had no idea where I was on the ride, but it was exciting.
Thanks, Dr. D. Now we have some practical space travel experience.
You're welcome. You'll be great astronauts. Oh, I've got to run. See you later.
Bye, Dr. D.
Bye.
Thanks.